elements and remove some elements as well. So the next way of storing data is graphs. So one node is linked to another node. It's kind of similar to trees, but um, trees are connected only. So we've got like the main element, and then we've got children, and here we can connect it like more freely. So for example, in our case, we've got A that connects B and C, B connects A and D, C connects A, and D connects B. And so for example, we can have the access to B and C through the node A. So yes, it has some disadvantages. It can use lots of memory, and it can be complex. And if we've got large data, it's hard to visualize it. So the next way of storing data is hash tables. So for example, here we've got Anna, Ben, and Kara, and they have some specific numbers. And if we want to get their values, we can easily get the access by just writing their names. So, for example, here we are accessing the number 85 by just writing Ben. If we want to access like the number 78, we can easily just write Anna instead of Ben, and we'll get that number. Also, it's very easy to add a new entry. So, for example, here we're adding done that has the value 70. And in the same way, we can get that 70. So it's very easy to use. But the main disadvantage is that it's not ordered. So yeah. So now I'll be talking about big O notation. So I'll explain what big O is. So basically we use it to compare different algorithms, how fast they are, and if the algorithm is slow, we'll be able to verify it by using big O notation. Specifically, I'll be talking about O1, ON, O log n, and ON squared. Right. So I'll start with O1. The best example of this can be, for example, we've got stored numbers, right? We've got an array, and we can get the access to any number just by writing its index. So if we want to get the access to 50, for example, we can just write 4 here, and we'll get 50. And it doesn't matter how big our array is, anytime we can just easily get the number. So what it means, one, that it always takes the same amount of time to get the data, and it's very fast. And if our data grows, we still get the data quite fast. So the next one is ON. So how it works, so for example, here we've got an array again, but it's so as fast, if it grows, then the difficulty to get the information growth again. So in parallel, so for example, if our array increases, so we'll get some numbers like 60, 70, 80, 90. Right, and 100 will have twice more numbers, and it will be twice slower than it is right now. So that's what ON notation means. And the name of it is linear time, so we've got like a line, like a straight line, and the more complex our data is, the more difficult it is to get it. So here is a good example. So we've got a loop, and like the more data we have in it, the more difficult, the more time it will take to like print every single number. So for example, before we had numbers such 10, 20, and 30, and we can just get any single number. It doesn't matter how big it is, but in this case, if it's bigger, it will actually work slower. Then I've got logarithmic time. So how it works, that's so we've got a list of numbers here. They are stored in order, and every single iteration of this loop we cut the half, and then we're comparing our target, so which is 9, in what part it is. So in this example, we'll throw away the left part and then have the right part, and then we'll do it again and again. So it works really fast, and we can very efficiently get our number very fast. The next notation is quadratic time, which is very slow. Is the slowest notation I've got in my presentation. So for example, here we've got 1, 2, and 3 array, right? And what we do, we've got a nested loop. So basically we've got a very complex way of operating with this array, and the more numbers we will have in this array, the much more time it will take to analyze this data and get it, because for each number we'll be making much more process in our loops. It's very inefficient, it's very slow. So here I've got just a comparison. I've got so all notations I was talking about are 1, logarithmic, and quadratic. And the fastest one is O1, and the slowest one is quadratic, which it just takes lots of time to finish that algorithm. So this is my summary. What I was talking about, all the data structures and big O notation. Right, and that's it. Thank you for your attention.